So the math behind DMRT. This one's actually quite a bit simpler, but it requires some outside resources. So to calculate this RP value, we first need the RP crit. And the RP crit is the RP critical value from the Duncan table. So that's a big table of values, depends on treatment orders and some things. We're not going to worry about that too much right now because we're actually going to provide that for you in the Excel workbook we're working on. Don't worry about that. Link in the description if you want to see the table though. Okay, so then it's RP crit times this SX, which equals the square root of the mean squared error over the number of treatment groups. Okay, so mean squared error, again, that comes from your ANOVA table. We're going to be using QE Suite to generate that with QE.ANOVA one way. So make sure you get your free trial started here. Link in the description that shows you how to get started with that in just a minute or so. And we'll show you how to do that when we get into the math as well. So our D value, that is just X bar. So the mean of the treatment group minus the RP value of the treatment group. Okay, so remember RP value is a little bit different for each of these because RP crit is going to be different based on the order of the treatments. And then grouping. So here's just a quick description of how the grouping goes. First, we'll order treatments by mean and descending order. So this is new data we're pretending to use here, where these are in descending order, 1, 2, 3, 4. Starting with the first treatment, we compare it with all subsequent treatments in descending mean order, and we step through. So first, we go 1 to 2, 1 to 3, 1 to 4. Then we step to the next, 2 to 3, 2 to 4. Step to the next, 3 to 4. And if the mean of a subsequent group is greater than the current group's D value, then they're grouped together into group I. Okay, that'll make a little bit more sense. But for now, that's the math. Super easy. Like I said, we just need some outside resources.